Welcome to another exercise in a workbook statistics. This time focusing on how to conduct a test to compare a mean, or the arithmetic mean of a sample, with a given test value. So let's have a look at the exercise. Here we have the leader of the market research department of an outlet center wants to check whether customers spend more money during the weekend as compared to the average. For this, the weekly average of 56.4 euros has been determined, as well as the averages for the last 4 weekends. Then we have here for the 4 weekends, well, that's 8 values because we have Saturday and Sunday for each weekend. And what should we do with this? Well, our task is conduct a suitable test at a margin of error of 5% to test whether a significant deviation from the weekly averages exists. Well, for this, we're going to actually need some additional statistics. First off, in either case, we need the arithmetic mean. But this can easily be determined by simply adding up all of our observations and dividing them by the number of observations, giving us as a final result 55.1. Then, that's the important aspect, in the exercise text there was no mentioning of a standard deviation or of a variance. So we need to calculate the variance and the standard deviation on our own. Since it's not given, and since we have less than 30 or 50 observations, we also know that we have to conduct a t-test. Because whenever the standard deviation or the variance is missing, and we have too few observations, that's where we have to use the t-test for sure. So well, in either case, we need the standard deviation. So let's start first off with the variance and calculate the corrected version, the sample variance, or the sample version of the variance, which here is simply taking each value, subtracting the arithmetic mean, and then the result to the power of 2. We're doing this, as I said, for each of our 8 observations. Finally, when we have all these expressions in the brackets, we sum all of this up. And the sum is then divided by the number of observations minus 1. Here we have 8 observations, so we're going to divide this by 7. Putting this into a calculator yields as a result 3.4457. That's our sample variance. As I said, we need the sample standard deviation or the corrected standard deviation. So what we're going to do is simply take the square root of the variance, giving us here a value of 1.8563. Well, so much so good. That's actually everything we need for the test statistic, but to conduct the test we also need a reference statistic to compare the test statistic to. Here, this is given via the respective required quantile of the t-distribution, which is as follows. That's the t, n minus 1, 1 minus 1 half alpha. N is the number of observations, so we have 8 minus 1. And alpha is the expected margin of error, or the accepted margin of error. So here 5% or 0.05. So we're going to calculate 1 minus 1 half times 0.05, giving us then 0.975. So we turn to the table for the t-distribution and look up the value t7 0.975. There we're going to find this value, the 2.3646, and that's actually everything we need to conduct our test decently well. So I'm going to summarize this on the next slide. Then, well, as I said, to conduct the test, we also need the test statistic. That's what we determined the first 2 values for, and the number of observations. So the test statistic for a standard t-test is given as number of observations, put here, taking the square root of them, then multiplied with the difference between arithmetic mean and test value, divided by the standard deviation. If we calculate this, we get as a result minus 1.9808. The minus actually doesn't matter because in the next step we're going to consider only the absolute thereof. So we're basically getting rid of the minus. That's in the test decision to do. Here we're going to compare, as I said, the absolute of the test statistic with our reference statistic, with the quanta we determined in the last slide. And we're going to see, or we're seeing here, the absolute is smaller, definitely smaller than the reference statistic. So this means the test statistic is absolutely smaller than the reference statistic. And this implies that we cannot reject our H0 hypothesis, meaning we have to keep this. H0 is actually the expression, the hypothesis that those two values, the arithmetic mean and the test value, are not significantly different, more or less the same. So this means if we cannot reject the H0, that the arithmetic mean of the expenditures on weekdays does not significantly deviate from the weekly given average. So this arithmetic mean does not significantly differ from this value. And well, that's everything there is to this exercise, to this test. So I hope you enjoyed it. I say goodbye and see you next time.